Question 6. A square wave signal with 0 DC offsets 6 volts peak and a period of 0.1 millisecond passes through a filter below which has an inductor of 500 microhenry, a capacitor of 500 nanofarads, and has a bandwidth of 2 kilohertz. So, what is the peak voltage of the output waveform? So we need to find out. It helps to find out what kind of filter this is. If we look at the filter, we see that at DC some frequencies are blocked. That way, that means that some frequencies will go through, but also some frequencies sink to ground. That means that at DC we'll have the lower frequencies being attenuated. Something is going to happen on the middle. Now, for high frequencies, the capacitor will short and will sink the signal to ground, and that means that at high frequencies the signal will be attenuated, and so something happens in between. So this resembles that this is a bandpass filter that has some cutoff frequency, has a center frequency, but from the information here, we're told that the bandpass, the cutoff frequency, give a bandpass, a bandwidth of 2 kilohertz. So we have a 2 kilohertz bandwidth on that filter. Let's determine what the center frequency is, because what's the question here? What is the peak voltage of the output waveform? So in order to know whether this filter will allow the frequencies that we want, that we are being asked through, we need to determine what the center frequency is. And also, because this is a square wave, we need to find what the fundamental frequency is, because they are asking us for the period. Well, they are not asking us for a specific frequency, but after filtering the input signal, we're going to have some waveform, and we need to find that. The center frequency for an LC tuned circuit is given by 1 over 2 pi and the square root of LC. We have those two values, so let's find that. We have 1 over 2 pi, the square root of the inductor, which is 500 microhenries, times the capacitor, which is 500 nanofarads, and the square root of all that, 1 over that. So the center frequency is equal to, let's punch that in, 1 over 2 times pi times the square root of 500 microhenries, -6, times 500 nanofarads, e to -9, and that's equal to 10 kilohertz, 10.06 something. So the center frequency is 10 kilohertz. Now, for the square wave, And the square wave, we use this expansion here. So we have that to find the fundamental, we can use 2 times the amplitude and pi, and just copying from the other page, the sum of 2 pi times n times t. So we need to determine what the fundamental is, and we are given that the square wave signal has 0.1 milliseconds. So let's go back on this space here. So f of is going to be 1 over t, which is 1 over 0.1 millisecond, and that's equal to 1 over 0.1 milliseconds, and that's equal to 10 kilohertz. Okay, so now what about the magnitude of the fundamental? So let's use this here, and we have the fundamental is going to be equal to 2 times the amplitude. The amplitude is equals to 6 volts, but it's not 6 volts because we are talking about here 6 volts peak. That means that we are given this here. From the sine wave, we're given 6 volts peak, the positive component of the sine wave. And the amplitude corresponds to both components, the positive component and the negative component. So we have that 2 times A is 2 times 12 over the first harmonic is going to be 1, so that's going to be 2 times 12 over pi times sine of 2 pi of n, which is 10,000 t. And that's equal to 24 over pi and sine of 2 pi of 10,000 t. Let's see, one more page to continue. Let me copy that. 24 pi over pi times sine of 2 pi 10,000 t, and we have that our bandpass filter has a center frequency of 10 kilohertz, and it has a bandwidth of 2 kilohertz. So the bandwidth is 2 kilohertz. Okay, so the input spectra we're going to have for a square wave, we're going to have a harmonic at, well, the fundamental at 10 kilohertz. Then we're going to have a harmonic at 3 times the fundamental, which is 30 kilohertz, and so on. And the fundamental has a magnitude of 24 over pi, which is 7.6. Now, I don't want to go beyond, and I won't bother about the magnitude of the third harmonic or the fifth or the sixth, because the bandpass filter has a bandwidth of 2 kilohertz and is centered at 10 kilohertz. That means that The filter will allow frequencies that are 1 kilohertz to the left, which is from 9 kilohertz to 11 kilohertz. Anything beyond those frequencies will be attenuated. Therefore, the peak, the question, let's go back to the question. The peak voltage of the output waveform is going to be 7.6. So we have a waveform that has a peak voltage of 7.6, but also has a negative 7.6 volts for the negative component of the waveform. The amplitude is all that, but the question is, what is the peak voltage? And this is the peak voltage. So the answer, B peak, is equal to 7.6 volts.